Everybody, thanks for attending tonight. This is CTI Virtual Classroom. This is our second session with ADAS Problems and Solutions. Our presenter tonight is Keith Perkins. Wave, Keith. Nice shop you got there. Our panelists are Jeff Miller, Jim Kokonis. Rich Falco is going to join us in just a few moments. Before we get started, let me take you on a little tour of how you can watch out for future events and register. This is going to be CTI online. So let me share this screen with you for just a moment. And when you go to CTI online for the first time, you're going to see this little splash banner that's telling you what we're up to. And it talks to Virtual Classroom, and it also talks to the World Professional Automotive Community, which is being presented by our sister company, WorldPack. You can schedule both of those from this website. When you go to the main page, want to hover over training, come down to Virtual Classroom, click on that, and you're going to see this chart. Pick out the time you want, the course name you want, simply click on register, and you'll be sent an email to register. Please do register, pre-register for that, and you'll be all set and ready to go. You'll also expect some follow-up emails, reminder email and follow-up email after the program. So that's the nuts and bolts of how to find us. Okay. Let's go back to the team, and without any further delay, I'm going to go ahead and turn this over to Keith. Jeff, Jim, myself, and Rich will be monitoring chat, monitoring question and answer. So please use that question and answer for any pertinent questions along the way, and we'll watch for chat also. So there's our Rich.
All right, so this is an excerpt from the ADAS Problems and Solutions class. We're going to start this one out. I want to, first and foremost, I'm trying to keep this as interactive as possible. So a couple points in times I may ask you to present your questions in the question and answer form at the button at the bottom. And then I'm also going to ask at some points for you to raise your hand, either in agreement or disagreement of certain things to help kind of guide where we go. And then, of course, I'm going to push off to our panelists as well, because they're here for a reason. What I find the most important about every situation in advanced driver assist systems is the sensor fusion that's involved, both due to the overall resolution that it provides by having multiple systems overlap and cross-check certain things. That's the biggest part, but I do want to pose a question just in the very beginning. If you guys want to post in either the chat or the chat preferably, I think would be better. Do these things set misalignment DTCs? Can we have a misalignment DTC on a camera or a radar system or any of the other ones? And if so, how? How do you propose that that's set? Anyone on the panel care to give a shot at answering that?
Okay, well, I'll speak to that. You were hoping I was going to say that, weren't you? Anyway.
I was.
Well, you know, you think about those misalignment codes, and the question comes to mind, how does it know? And it knows by comparing. So the question then is, what does it compare it to? So I'm going to turn it back to you, Keith. What do you think those comparators could be?
Well, it goes right back to what we were talking about, specifically the sensor fusion. So that overall resolution is due to multiple systems looking in the same direction of travel and measuring some of the same things. I would think that if one or two of those systems is identifying one direction of travel, one distance of an object, and another one is off, that is where our DTCs would most likely come from. Of course, some radars and front-facing cameras have other things. If we've pre-calibrated them and then there's been an adjustment and now something's off, and it's going to be looking to other systems as well. Some that aren't even on this list. This is a nice graphic that shows some of the advanced driver assist sensors that are put on the vehicle, but there's all kinds of different variables. And we're going to talk about a few of those as we go along. Biggest part to consider when working on these systems is to create a step-by-step process. Just like anything we work on, we want a diagnostic process. So things we would want to do is verify the concern, because we've all dealt with a situation where we fixed something that we thought was the customer's concern, but it really wasn't. That's run into that many times, especially with noises, vibration, even simple stuff like that can easily be overlooked as your concern versus the customer's. A big part of this is considering our environment, especially when we get to the actual calibrating these systems. Things to take into effect are how do radar work, how does the front camera work, and what things in our environment could affect those. But we want to start with after we've considered those things and verified. There's a few other steps we're going to go through, but preparing the vehicle is one that gets overlooked a lot. So I kind of wanted to touch on that, specifically tire pressure, fuel levels, and then modifications and thrust angle are all really big as well. And we could spend an hour talking about just thrust angle, and I got a better slide where I can give you some numbers for that. Randy had a good example. We're at the research center with tire pressure. I believe it was the driver's front tire was low.
That's correct, Keith. Driver's front tire low, and only by about 8 or 10 pounds.
Right, and they made a laser mark at the vehicle of where the center line was, and then they properly aired the tire up, and there was, what'd you say, like almost a quarter of an inch or more of movement?
Almost 3/4 of an inch of movement.
Almost 3/4 of an inch of movement. So you can imagine at a distance how much that changes. And when we get to the thrust angle, I'll give you some numbers of how big a small variance that close could be affected at a distance. But another question I kind of want to pose is ride height and modifications are on here. So I'm from Oklahoma. Just about every truck has an aftermarket larger size tire and or a body or some kind of lift. New car dealers are modifying these vehicles and selling them as a factory lifted vehicle, and they've got aftermarket components. So can anyone elaborate on how they think that will affect the system? Again, in the comments section is a good spot to kind of put your thoughts. And does anyone on the panel have anything they can say to that, Jim?
I guess I look at this from a couple of different points. Mm-hmm. One of them being that I know certain manufacturers have actually written updates for the systems to allow them to operate in the new geometry and the environment that's set in. And then I guess, can it be done and can it be done safely? The answer appears to be yes, because of what we see the manufacturers doing. If you look at a brand new Tacoma, you will have the safety sense system on anything from a 2-wheel drive, low slung pickup truck all the way up to a Tacoma TRD Pro. And they're all running the same basic components, but the calibrations are tuned for the way the vehicle's configured.
Right, and that's on the factory side. So when we start to modify on our end, if we're modifying from one system to maybe trying to replicate a TRD style, but we go outside of that normal realm, there's no telling. There's all kinds of variables, right?
I'm out.
Right, exactly, and that's
where I walk away.
That's exactly where I wanted to go with that too. Is at what point is the point of I'm done with this? So all things have taken effect, and I don't know the answer. I don't think anyone knows the answer to that. So there's a lot to think about there just in the preparation of the vehicle. A big part is referencing service information. That's a big part of anything. If anyone has ever sat through anything I've talked about, I will probably annoy you with how much I say, well, what does the service information say? Because it's rather important. Looking at TSB specifically and any of the procedures, I want to say the biggest part of this is look at the most up-to-date information. If you're using an aftermarket, quote unquote, service information system, which most likely is just regurgitating factory information, when was that last updated? Because my example I use is Toyota. I believe I didn't even look this up last time, but there is a year, make, model, and I think Jim will know which one it is, but they've done 3 revisions of the procedure and nothing on the vehicle has actually changed. They've just found a better condition to put the vehicle in or a different distance that makes for a more accurate or a higher resolution calibration in the end. And there's not been any change to the actual vehicle itself. So other things to do, looking at doing full network scans, then we got to perform the calibration and then our post-calibration procedures. So I skip over those because we're going to talk about them more in depth, especially in the actual case study of why we do those things. But I can tell you that having at least this as a minimum setup is going to be important before you continue on.
Hey, Keith.
and having this set ahead of time. Yes, Rich.
There was a question, and it's modified vehicle, so I figured while we were on that subject, Bennett Varnado, I probably butchered that name, I'm sorry. Could a lifted vehicle throw the sensors off far enough to not recognize another vehicle in a blind spot or adaptive radar or cruise control, is the question.
I would say absolutely. And then when we get to this thrust angle slide that I've got here, again, I'm going to have some numbers for you of how little of a movement off can adjust how far of where it's looking. We're going to have some actual numbers for you.
Yeah.
So we will cover that pretty well.
You know, that's an absolute yes, but I want to add just a touch to that if I can. Mechanics logic, no offense, mechanics logic might say, well, if we lift the vehicle and we aim that radar or aim that camera down just a little bit, wouldn't that suffice? And the answer is no. And the reason is that you have to consider the top portion of that window, visual window, and the bottom portion of that visual window. And at the correct ride height, it has a certain spot in the road that it starts and a certain spot in the road that it stops seeing. Depth of field, if you're a photography guy. If you lift that vehicle and recalibrate that sensor at a more downward angle, you limit that depth of field. So could it see something? Yes. Would it see something at the right time? Probably not. And so that's the concern. Now, GM did come out with a lift kit and a software calibration for Silverados about a year ago. And it was a 2-inch lift kit, and it recalibrated the sensors to work with that lift kit. But 2 inches is relatively mild. You start getting into 4, 6, 8-inch lifts and oxygen mask lifts. You know, that's a whole nother program. So.
But even at a 2-inch lift, they recognize the need for a calibration to adapt all of the systems.
Absolutely.
So that's important.
Mike, Keith.
Yeah.
Mike Robinson actually pointed out that Honda has gone back and started to require calibrations on older models that they didn't used to. And I completely agree with what he says here. It's just because you've done a car before doesn't mean you don't keep going back and looking to see if something's been updated. Because
so I should throw away all my laminated service procedures from those.
Exactly.
And it looks like Honda is requiring suspension alignments also before any kind of calibration. They want to verify that center line is actually the center line.
Right. That's important. So when we talk about performing the calibration and considering our environment like we talked about before, a big part is your shop area, right? So seeing that previous slide that I just moved away from, there is a small diagram there with this one particular vehicle requiring a 5,000 millimeters, which is the measurement from the front of the bumper to the target area, an area where the target would be on that Toyota, which is 16 feet. So if you guys start to think about in your shops, do you have 16 feet clearance? Maybe if you move the vehicle all the way back. So there's lots of measurements out there. This picture was submitted by Bob, and this is I believe this is an area he's designated to set up as a calibration area. If we look, you can see that the walls are pretty neutral, and this target here on the back with the 6 dots, that's a Honda lane watch for the side mirror. And this is a Toyota, so this is not, representative of the actual distance this would need to be, or even where it would need to be at all. It would need to be at the back of the vehicle. But this gives you an idea of how big of an area this individual, who's done a ton of calibrations, has identified as a space that would be adequate to perform this. You notice all the lighting is specific. There's not casting shadows in any one direction. The walls are pretty neutral. So by a show of hands, there's a little raise hand button at the bottom there. Who has a space like this, or that you could consider about 16 and a half feet in front of you in your shop, that isn't currently doing this? Someone who hasn't moved all these aside and set an area, who can think of an area in the shop that they work in that could do this?
No one.
So we have 2 participants.
Yeah, we've got.
Come on, don't be shy. Raise your hands.
Yeah.
Okay, so all 2 of you are prepared. So that's another thing to start thinking about on these static calibrations. We haven't really got a whole lot into static versus dynamic But just be aware. Okay, 8 participants. Look at that. Now don't be shy. 7. Somebody, never mind. They said never mind. A static calibration is one that would involve a target like this one seen here in the picture. A dynamic calibration is one that would involve putting the vehicle under certain driving conditions while performing a command function to a module or series of modules in the scan tool. And again, it's so difficult to pack all the aforementioned needed information about advanced driver assist and cover this case study. But this case studies we're going to use is going to kind of highlight some of the possibilities that are out there. Another good example of area is some pictures taken from Toyota service information. And a big comment that I think I hear a lot is that, well, those resolution in the pictures they took are terrible. Unfortunately, these are the resolution from a camera that's used. The megapixel of the cameras used in most of these forward-facing camera setups are about 1 to 2 megapixel. Randy, I think is what you found.
Most of them, yeah, that's correct. The exception is Subaru EyeSight, but typically most cameras are very low resolution.
Put that in perspective, a cell phone from 10 years ago probably has twice the camera that we're talking about. So it's very low resolution. So if you start to look at these pictures in this top left one here, lots of those things show contrast. That's what the camera's looking for, is the contrast of the colors in the shape of the target.
Hey, Keith.
Yes.
I'm sorry. There was a question. Can we do this outside on a level surface?
That is a great question. This can be done outside on a level surface, but there's a lot of variables. We start talking about lights, overcast, wind. If you're using the Toyota stand is a 4x4 wood block with a metal insert in the bottom and a 48.5-inch wood stick with a wind sail at the top that looks like a target. So a small little gust blows this thing over. Or makes it wobble or move around. And so the probability is, yes, you could do it. Absolutely. I mean, given all the right conditions, but that's very difficult to judge that. Some areas you may have 1 day out of a week that you could do this. Some areas you may have 1 day out of a month you could do this.
And it also depends on what we're calibrating, because some radars aren't affected by light. So
right.
It depends on the target and the car specifically. Yes.
This particular example, yes, static calibration with a camera is highly dependent upon the environmental. But like Rich said, some radars, I do most radars outside because it's easier.
Me too.
I can get more space.
Excuse me. Can the attendees see the video feeds from all of the panelists? Can you guys chime in whether you can see the faces of everyone? No, you only see just Keith.
Okay.
Just Keith.
That's a good thing.
Just change that for a minute.
I did.
So can you guys see me now? Only Keith in the slide. Yes, now it's changed. Okay. All right. So when we think about doing something outside and how a camera can react to changing lighting conditions, just take a look at my slide once and tell me whether or not uncontrolled lighting from outside would change what the camera sees. Just a thought.
Yeah, and that camera you've got is designed for variable lighting conditions and designed to adapt.
Well, there's another point of view of outside or inside also. Now, real world, can we calibrate a vehicle outside? If the conditions are just so, yes. Unfortunately, you see a lot of instances where the conditions aren't so, and calibrations are being done, and even though the scan tool reports it was successful, it absolutely isn't. But the other perspective is this: what about liability? If you've got that little courtroom in your head going on, and somebody in $1,000 suit asks you, "Did you follow OE procedures to the letter?" and OE procedures say something about doing it inside or not doing it outside, that could be a case. So, what's real world and what will work is often not in agreement with what is the best thing to do liability wise. And that's a hot button topic. We're not going to debate that tonight, but it is something to keep in mind.
That's a 1 hour unsponsored panel where we all take off whatever work shirt we're wearing and have a conversation.
Yeah.
So one of my favorite topics is thrust angle. And because we do have some good numbers, because, Jim's done some good work on this, as well as Randy, on getting some numbers. But I think what is stated is that thrust angle needs to be correct and within specifications. So the number that's stated here is that 1 degree of deviation of thrust angle equates to about 63 inches off at 100 yards. So what we're saying is, when you calibrate the thrust, when the thrust angle is in alignment, at perfect alignment, we're good. What's in front of us is what's in front of us. But if our thrust angle is off and we make this calibration and it's only off 1 degree, that device that was right in front of us, or the car that should be directly in front of us, the way the thrust angle is affecting the vehicle body and everything, and the way we're looking, the object in front of us that's 100 yards in front of us is actually 63 inches to the left or to the right of that. And then I think Jim brought up a great point, is that most of the distances of these radar and the other device we're using are about 200 yards. So if that's where it's looking, we're doubling that. That's 126 inches, which is, a little over 10 feet. That's in a different lane. It could be an oncoming traffic lane. It could be an additional lane that's just not there. So if it's looking there and we have a car that we're quickly approaching, the adaptive cruise control or the emergency braking or collision detection avoidance system that's there may not act until it's too late. And that's a problem. So if you go to test the vehicle and you go, oh, this works great, I didn't even need to check the thrust angle. It works. I calibrated it and I went and made sure I almost didn't hit the car in front of me at 30. Well, at 60 or 70 miles an hour, you may have a completely different experience. So that's why we want to follow all of these procedures. Following OE procedures is what gets the job done correctly. So, and how close is close enough? How is it supposed to be? Audi states that 0.2 of a degree is the range of acceptability to our target number. So you could be 0.2 of a degree off. So that's not a lot at all. So it's got to be close. It's got to be right. Other players that take into effect of this is steering angle sensors. Again, I asked this. I want someone to put it in the chat, guys. Why do you think steering angle sensors could have anything to do with this system? Yaw rate and accelerometers, I get it. We're dealing with collision avoidance and braking and all that. But how could a steering angle sensor play into the system? How could it affect how this system recognizes devices in front of it, or however you want to do it? Chris Groff says lane keep assist. Exactly. Perfect, Michael. I like the way you worded that. Michael Phelps says steering angle is the input of where the driver intends to go. So intent. Exactly. So it wants to anticipate where we're going, right? That's the entire purpose of this, is to pre-collision avoidance, to attempt to avoid problems, or just increase the comfort level of the driver in the event that they're not paying as much attention. Good. So that's going to play into our case study as well. A really good story I think Randy had was what this picture has to do with, but updating your tools, updating your VCI, make sure the firmware is up to date, and then ensuring, again, you're following exactly what the current most up-to-date OE procedure is really important. Randy, I think you could probably tell the story better. You were there.
Oh, okay. Well, this group was at the research center, and very intelligent group of guys. We had some that were Audi specialists, and we had an Audi that we were attempting to calibrate the radar, and it wouldn't calibrate and wouldn't calibrate and wouldn't calibrate. And we had some remote help log in, see if they could figure it out, and even had the factory service information. And everybody had an opinion. Everybody was doing their very best to solve this problem. And so it was a very busy environment, to say the least. Bottom line is the day ended and the car wasn't calibrated. So just consider that an environment like the heat of battle in a shop that we face every day. So everybody leaves. I'm there by myself. I go back and think to myself, it's got to be something just simple. And sure enough, it was. Everybody had looked at the specs, and everybody had looked at the specs incorrectly, and the target was just not placed at the right distance, or the right height, excuse me. Placed it at the right height, went right through, no problem. And that just demonstrates that in a lot of cases where you have a car that just refuses to calibrate, the the problem is just very foundational once you dig through all the fluff.
Perfect. So goes back to following a step-by-step procedure and being methodical with it and paying close attention, not just brushing off numbers, being very, very specific and intentful with all of our measurements and movements that where we place things. Because that could I'd probably set back some serious time. I know that if you attempt to calibrate one and press the button and it goes and completes the calibration, but you have it in the wrong spot and you find out during your test drive, you've got to set it all back up again. Don't ask me how I know. So I would go into what is our step-by-step processes with one of our most important processes that we would do, which is an all modules scan. Regardless of what was done or what you believe was done or what you know needs to be done, an all module scan is important. And we talked about sensor fusion a bunch. So in this example we're looking at here of this aftermarket Autel scan tool, there is a adaptive cruise control fault, right? And then we have some other advanced driver assist related modules, which is denoted very helpfully in the Autel by having this little blue icon to the right of where the fault is listed, identifying that this module has some advanced driver assist functions in it. So is there any way that the blind spot sensors could have any kind of bearing on the adaptive cruise control or vice versa? And if we read service info, depending upon vehicle, the answer could be yes, it could be no, depending upon what you find in service info. But based on practical application, what we found is that most likely you can have some kind of effect. Any fault that's beyond just, hey, we need to calibrate this, could easily prevent a calibration from completing, whether it be in the module you're working on or just an associated system. And as we go on this case study, you'll kind of see that things that you don't immediately think are important can be very important. And I would give you that as a clue, and we've already given a couple clues as to what could happen in the worst case scenario. After you complete your calibration, you would want to do a DTC check and clear. And I would say to do that, my recommendation of not recommendation, I can't really recommend anything. What I can tell you that I do on a personal level is that once I complete a calibration, the moment it completes, I safely get off the road at the next turnoff or wherever it's safe. I do a DTC check and code clear if the calibration went through successfully, because there's almost always a DTC that's set during a calibration, depending upon the vehicle model. I don't notice as much with Toyota, but some of the domestics doing dynamic calibrations, they do set DTCs just from the calibration process. So I'd want to clear that. So I start with a clean slate and then go perform my drive cycle and OE verification process by attempting to use all of the associated systems. I personally try to attempt to use all advanced driver assist systems. I usually have to go in and turn those systems on or off. And I make notes of how the customer had the system set up beforehand. The most recent one I had that was way off was I had done a Ford and the customer had almost everything turned off. So I went through and turned all of it on, made sure it all worked and functioned to what I thought was normal according to service information and what I could find under description and operation, and then put it all back to the customer specification, because I don't really want to mess with something and create a false customer concern just on a system acting outside of how they have it set up or how they receive the vehicle. That's a whole nother kind of thing, going to look and deciding if we should educate the customer on everything the car can do. So looks like Paul Smith has a question. I used an alignment machine that I didn't trust. Is there a way to verify thrust angle is dead on? That's going to be difficult without
Welcome to my world, Keith. Paul always stumps me with questions in my classes.
That's a really good question. Well, that's good. That means he's trying to think of what could happen that could prevent him from doing his job. That's kind of the way to think.
Yeah, he's great.
Actually, I just typed Paul and answer. It's kind of tongue-in-cheek, Paul. So
typed him an answer.
Yeah, I did.
It is slightly baffling to say the least. Okay, I'll agree with that. I'm going to have to study that and find out. So my big harp on that one is spend the 7-10 mile, set up some kind of standardization of what you'll do with each type of system and do your best to put it through its paces to ensure that it works correctly. Because I can tell you just what Randy just stated, you can easily get one to calibrate successfully and be wrong. It could absolutely not function correctly. And I think Jim, Randy, and Rich have all done them purposely wrong to see how they would react before putting them back to factory exactly how it says according to OE specifications with OE tooling and stuff.
We always have to remember.
I did it wrong on purpose. That's exactly it.
Yeah. We always have to remember that just because the scan tool says it calibrated successfully, that really doesn't mean anything until you verify it.
Right, and you can do that and get no DTCs by just doing a code scan and check, and it may not code ever, or it may not code for a long time, or it may code on the first drive. I'd really not want to do the research to find out when. It's much easier for me just to do it the best I can, as close as possible as I can the very first time, and go on from there.
So you wouldn't want to use a fold-up engine stand to calibrate a blind spot monitor?
Nope. I'm not saying I wouldn't try, but
Yeah.
right. So now
that's a story for another day.
Yes. Now the beautiful vehicle in question. It is a 2018 GMC Yukon Denali. The customer concern is a service driver assist system error on the dash. Now, it was noted that the cruise control was non-functional, and there are actually a couple of the lights on at the time. This vehicle, for a slight amount of backstory, was a total loss and then purchased by a rebuilder, and was cosmetically put back together, and is requesting to have all the lights cleared, basically. And like I did last time, to head off the question, I don't know the legalities of doing that. I just know that in the state of Oklahoma, if you go through all the necessary processes, you can get a rebuilder's license, and that is something you can do legally, is buy a total loss vehicle and fix it to a certain standard and get a rebuilt title for the vehicle. I do not know if that can be done everywhere. So just to head that question off right off the bat, but what I will preface that all, or what I'll suffix that all with, is by saying that this car didn't have to have a total loss event in order for the issues that arose from this vehicle to happen. This could happen on a vehicle that has very minor damage that was not a total loss. So don't let that play into any of the reasoning in this. So we started with a full system scan, just as we want to always try to do, right? When we did this, we used an aftermarket scan tool. One thing that I wrote, what do we look for specifically when we talk about aftermarket scan tools, is what I found in my experience is that an aftermarket scan tool can do a full system scan and cannot communicate with modules that are either not communicating or may not communicate with a module that does exist and has no problem on the vehicle, and it will completely skip over that. And some factory scan tools, I believe, can do that as well. But that's just something to take into mind when you're looking at these things, is that that you could, using an aftermarket scan tool, you may miss the module. With that being said, I used an aftermarket scan tool in this job. I save all my pre and post scans. Every time I scan the vehicle, if anything has changed, I save it. So please document everything. That will, one of the biggest parts of protecting yourself and just having a good record of what you've done. So the DTC in question, after a little bit of investigation, was the C056E, electronic control unit software was the DTC definition. A little descriptor to the side says calibration not learned. And now that's in the distance sensing cruise control module. So a little bit of backstory on the vehicle. We started questioning them about this code, what was done, how was the vehicle damaged, where was it damaged, all the fun questions, and prying out all the information. We determined the little black box on the front of the car behind the bumper was replaced, as well as other random components. Airbag stuff, all kinds of fun stuff. As you can see in the DTCs, there's a laundry list of things. That little black box was the distance sensing cruise control module. So we decided, all right, let's look up the service information and find out what needs to be done. We know for sure it's self-reporting that a calibration is not learned. So at very least, we're gonna have to calibrate this module. So looking at the service information, we jumped right into it and kind of skimmed through the information. And we noticed that step 6 is perform SPS, distance sensing cruise control module programming, and then perform the distance sensing cruise control module configuration. And then at that time, a C056E with a failure type 4B will set as a result of the programming event. And that's the prompt for the configuration, which is the learn procedure. Now I'll also say that this vehicle is a 2018. So anything post 2014 is a global A architecture vehicle, which means that the SPS programming system for GM will also perform all post module configurations and setup that needs to be done. So we would not actually need an aftermarket scan tool or any additional scan tool to perform this said function. To do programming and configuration, you wouldn't need another scan tool. Now to do DTC scans, all the rest of the data we need to look at, and maybe look at some live data during our test drive, you would need a scan tool to do that. But just a helpful hint, if it's a global A architecture vehicle, you actually won't need a scan tool to complete the calibration. So we actually calibrated, we programmed the module, just did an SPS event to program it. Then we went through and go, all right, so now we've got to do this configuration and we need to read some service information like we talked about. We need to be familiar with what we need to do this actual calibration. And the most important things I noticed were in step 6, which if you noticed, that would mean there are 5 other steps before that. So things to take into mind. Things to think about before you jump into this is maybe reading all of them carefully. But what I took from this was the conditions at which we needed to drive. It may take somewhere between 10 and 30 minutes. May drive at speeds greater than 30 mile per hour. You need to minimize tight curves, avoid extreme acceleration or deceleration, and drive in an environment that has stationary objects on the side of the road. So in the chat there, you guys put out maybe some reasons why you wouldn't be able to perform this? Start thinking about your shop environment, where it's located. Maybe start thinking about the times of days that you would have to do calibrations. Ooh, Todd, good one.
In a Lamborghini?
In a Lamborghini.
What is snow?
It looks like something about a clarification for Matthew's question.
Pre-COVID traffic. Sorry.
Yeah.
Oh, are you looking at Matthew's question, Jim?
Yeah, I was, and
Okay.
and when he had it up in Q&A, I didn't quite understand it, and so I asked him to clarify, and he did that in chat. And I actually think it's an interesting question, so I'll let you decide if you want to do it now or later.
I actually didn't get to read it, so if
he was basically expressing that if a customer comes in for some type of service, and Matt, if I say this wrong, just chime back in chat, and they have a feature turned off like lane keep assist. When you're done with the car, do you give it back to them with it turned off or with it turned on? And I thought it was an intriguing question. And my head went right to the document I've seen about the ADAS features that customers like the most and the ones that they find most annoying. And the example that he chose for that question is the one that most customers dislike, because the lane keep assist forces them to be more precise than they tend to want to be.
Mm-hmm.
And so they don't like the lane keep assist constantly fussing at their driving behavior. So it's one of the most likely ones to find turned off if the option is there. I don't know how I did with that, but that's
Jim, I'm gonna let Matt talk here if he'd like to chime
perfect.
in. And
see if we address that for you, Matt, the way you were asking.
okay, Matt, are you with us? He may not have. Oh, there we go.
He may not have mic capabilities.
Hey, Matt.
It says he's unmuted.
Can you hear me?
Yes.
Okay. Well, we replaced windshields, so lane keep and departures and all that's our main field there. So we're test driving them, and I just feel like it should be left on, and that way the customer has the choice of turning it back off or on. Because how am I going to say that, they wanted it off and needed it to keep off? I mean, do they even know it works? Do they just get the vehicle, or
Do they even know it has it?
off?
Yeah. Well, that can go a couple of different ways. The first way is that they had it turned off for a reason, and now it's on, and it causes some irritation with the customer. But the other thing is, if that was off and off since the car was new and they're not aware of it, and now it's turned on, now they think the car is doing something that it shouldn't do because it's got new behavior. So
Right.
it's, at the end of the day, I think it's just a great opportunity to have a discussion with your customer, and you have an opportunity to educate them, or maybe they have an opportunity to give you a little more insight on how they like their car to operate.
Right. And I've seen some friends of mine that do calibrations even have a pre-printed off a sheet that stays with the vehicle that says what was done. That says that we turned on all of these systems and left them on. And I've seen them say we would do it the other way. We turned all these systems off because that's how we found them, or whatever. Some just pre-made sheets of how they set them up. So that's something to think about. That's where it goes back to what I was talking about before, the customer education part. You may need to have that conversation first before you even decide what you're going to do. I don't know if there's a right answer to that. Did we answer that adequately for you, Matt?
Yeah, gives me a lot to think about.
Okay.
Yeah. Good.
Well, thanks, Matt.
Yeah, thank you.
Hey, Keith,
Yes.
question from Joseph. We'll just leave it at Joseph. Sorry, Joe.
Yeah, Josie.
Yeah, Joe M. Were new modules installed, or did they use previously flashed modules? I don't know if he means used or reused old modules on this vehicle.
So the actual physical module in question that was originally on the vehicle is here. You won't be able to really see it very close, but it is decimated. This would not go back on the vehicle. They installed a brand new module, I believe, because a used one couldn't be sourced. I do believe that if a used one could be sourced, they would have attempted that. Which goes into a whole nother thing on its own.
Yeah.
Let me just say that with a large asterisk at the end of what I'm about to say, is that on 2014 and newer, or any Global A General Motors vehicles, it is highly probable that a used module will not work, and most likely will prevent the vehicle from starting or causing other modules to have permanent problems. Very large asterisks on there. I can talk for about 2 hours about that. So I would just say used is definitely the only way I would recommend, because I think that's the only thing that the manufacturer would ever recommend on any kind of safety item.
Did you mean new?
New, sorry. Yeah, new. Did I say used? That's terrible.
Yeah, it's okay.
Oh, completely. Somebody, all right, we're not using this recording.
There's a lawyer screen cap that one.
Yeah. I meant new. New only. From the dealer, original equipment manufacturer part, something like that. Yeah, so where's the point of no return? Do we go out and do this? That where's the point of no return is a cue for me to give you a small tidbit information that will come up later as well. That in my experience, this is not listed anywhere, that if the calibration is going to go swimmingly and complete, whether it be correct or incorrect, if it's going to complete quickly, it's going to complete very quickly. If you reach that 10-15 minute mark and you still haven't got a completed calibration, you will probably have a fault. That's just my experience. There's nothing written anywhere to endorse what I just said or in any way corroborate with service information. So what kind of things could prevent a successful learn? Well, we talked about those. You guys kind of gave some thoughts. There was a lot of really good ones. Snow, traffic. Of course, we brought up the pre-COVID-19 traffic, of course. So there's a lot of good stuff. Somebody asked what size objects should be on the side of the road. I think a little further investigation in the service information talked about guardrails and barriers. So they're probably looking for something rather substantial, or at least something that a radar could reflect off of. So if there's one of those orange fence line things for construction, that's probably not what they're talking about. So we actually prepared this vehicle after we performed the programming event. We went through and prepared the vehicle and checked the tire pressure, went through all of our checks. We had already done our pre-scan and kind of got an idea of where we needed to start on this vehicle. We planned out our route because we were kind of concerned about maybe traffic and determining that this body shop area was close to a highway, and that was probably going to be most conducive to meeting as many of those check mark requirements on the service information as possible. And we determined on this one I was going to use an aftermarket scan tool, both to test the ability of the aftermarket scan tool to actually send this command, and see how closely it mimicked the OE SPS prompts, because I had done many of these General Motors dynamic distance sensing cruise control module calibrations before. And I will answer a couple questions about the aftermarket thing real quick. Just keep in mind that an aftermarket scan tool is simply requesting that a module does something that's already in the module. That procedure, the software, the programming on how the module is going to perform this calibration is in the module itself. That's something that we probably just programmed into it during our SPS programming procedure. So all we're doing with the scan tool is requesting that this scan tool do its thing. So I'm not saying that every scan tool that has this button will work, but what I'm saying is if it has the button, you press the button and it correctly sends the correct command to the module, then from that point forward, it's all on the module. Everything you're seeing feedback-wise, all the data that's used and acquired, all the radar sensing technology that's happening is all done in the module. You're just sitting there receiving data back. So something to think about when you start talking about aftermarket scan tools is will they work, will they not work? I don't know. I know that the OE scan tool will work, and that I confirmed in this one instance on this one vehicle with this one version of aftermarket software, this one time, that it did function. Was that good enough, Jim? So the test drive outcome, well, we drove the thing, almost took 30 minutes. And as I kind of alluded to before, that most likely gave us an idea that there was going to be a problem. When we did this, the telltale light went out, which is this green flashing light here up at the top right. That's what it looks like on the dash during the entire calibration. The message went off, and then about 5 seconds later, immediately came back on. So we knew that there was an issue, so we went ahead and just re-performed the scan to see where we stood on service information now. What had happened? Are we getting the same fault? Are we getting a different fault? Where do we go from here? And we were actually given a different fault, a C1002, the distance sensing cruise control module performance error. And we actually went into the module to get more information, because there is descriptor codes at the end of these. This descriptor was 66, which meant incorrect mounting. So now it's time for us to physically inspect the module, because if it says incorrect mounting, we're assuming it's talking about the radar is incorrectly mounted. And to do this, we have to remove the bumper. And I can tell you the bumper is labor intensive to remove off of this vehicle. So what we did is we had them remove the bumper, and this is what we found. Now, I don't know about you guys, but I've never seen this whole 2 nuts and a bolt pointing the wrong way and with a couple extra washers on it used in a factory setup. And this bracket that this bolts to looks probably not in new shape. And I apologize, I didn't get a better picture, but from underneath, you can kind of see it right here at the bottom of the bolt. This frame horn is bent, and then there's some welding over here that's been done. So if you look kind of closely, it's she broke. It's bad. So at this point, I said, well, what is this supposed to look like? Was really my question. So we pulled some service information pictures, and looking at them, there's the mount that inserts into the end of the frame, and then 2 bolts that holds it, and then the radar bolts on the front there. Looking at it, decided that this is probably not right. And doing some measurements and looking pretty closely, I actually determined that this vehicle needed a front frame section. The left front frame section that comes out was far off of its center line, looking down the frame according to the other side. Then I found some pictures online and determined that this is supposed to be pretty straight, and it was visibly not straight. So they had cosmetically repaired the vehicle, but underneath it was still ugly. And so at this point, I told them they're going to have to replace this front frame section, and then I would have to come back, or the entire frame. Now, the front frame section was available for this car as a part number that was a bolt-in unit. It does have a section behind the engine that had to be replaced. So they had to, support the engine and transmission, drop the rack and the front suspension, and replace this. So it was several months. And I actually didn't quite mention this, but if you look at the very beginning, the pre-scan we did of this vehicle had nearly 5,500 miles, right at 5,500 miles. And when we get to the end of my post-scan, I'll show you the mileage, but this vehicle was being driven between all of these sections of repair. This vehicle took me nearly 6 months in total to complete, but there were lots of other issues. So just right off the bat to let you guys know, this isn't something we were able to sit there and work through an entire day. These parts took weeks sometimes to order some of these components and go through for installation. So it's not something that that was easily done and very quickly done. So those are all things to take into account. How does that affect you in your bay? Should we make sure we read through all of this information first? Because why did this happen? Why did we miss this? Well, if we go and look back at that set of instructions where we harped kind of on steps 6 and 7 about programming and configuring, there's step 2 that we kind of missed, which is align the distance sensing cruise control module. And there's a procedure there. And the procedure outlines actually using a level and checking to make sure the module is straight, which we skipped. I will say, and this is, sounds like it's something I made up afterwards, but I did ask. I said, is your body guy good? Has he done these before? And he said, oh yeah, we've done lots of repairs. I said, is he good at like following instructions? Because this thing has to be aligned first and the bumper's got to be pulled off to do that. And oh yeah, my guy's good. I'm sure it's all great. And that really happened. That's what he said. And then of course there was this conversation once we had the bumper off. So after that was all repaired, the front frame section was replaced, a new mounting bracket was installed. It came with the hardware. There's actually, if you look close, there's a non-adjustable bolt at the top left, a non-adjustable bolt at the top right, which had actually, you guys saw the picture, a couple nuts stacked. And this bottom left is an adjustable hex head, an Allen head. The service information says to lightly press a level on the front. And the reason it says that is the front of this radar unit has a plastic cover that flexes. So you can kind of cause some deflection in that and maybe get an inaccurate alignment. So to carefully place this on there and then actually use the adjustment screw until the unit is level. And that's why I called for the frame section. There is no left and right adjustment of this, only one single adjustment. So everything has to be in line correctly first before this can be done. Now, an alternative to this level is something like this angle gauge that's used, and these are pretty inexpensive, and most of them that I found have been very accurate. And that was probably like $40 on Amazon or something. It's relatively inexpensive. Or you could use one of these $2, hardware store levels. And that I'm aware of, gravity is the same inside of every brand of level, so this one's probably pretty accurate, unless anyone's got any other experiences. So we performed the procedure again, and calibration went through no problem. It actually, the telltale light went off. The service driver assist message didn't go off, didn't come right back on. So we said, all right, this has got a clear code scan. We went ahead and re-scanned it. Now this ECM fault is something completely separate. So we went through with our verification test drive. We went through the same route, got right back at the shop, and we get a big blaring service driver assist system. Now, for lack of a better time and place to do this, what other questions do we have? I feel like I've rambled on for a few minutes.
I have one here that relates to your case. It's from anonymous attendee. So thanks for chiming in, anonymous. We found that white lines calibrate faster than yellow lines by seconds. Thoughts on solid versus dashed lines for a dynamic calibration? It's kind of an interesting thought.
That is an interesting thought. And I don't have any real solid data on that. For the same car repetitively doing a calibration, testing different sections.
Well, I believe contrast would have a lot to do with it. And
absolutely.
I wouldn't be at all surprised if solid calibrates faster than a dashed line does.
You would think solid white lines would calibrate much faster than dashed. Depends how yellow contrasts to the ground. I mean, what's the concrete mixture of that area? Is it asphalt covered? Is it,
another question that came up and relates to your case study is from Paul Smith. Thanks, Paul. Mm-hmm. Do you trust phone level apps?
I trust the technology in the phone very much. The 3-axis and everything that's in the phone usually works really, really well, very accurately. Things to take into mind of that I always like to bring up is your phone case. I've got one of these dumb pop socket things so I can, watch videos and set my phone down. And then my buttons protrude on the side. So all of those are going to affect how I put that phone on a surface. So those are all things to think about. I I would err on the side of caution and probably use what the manufacturer recommends.
I was gonna say I have used my phone and it works, but I had to take it out of the case.
Mhm.
And at that point, why not just buy the level and have the right tool for the job?
Right.
Todd Doty joins us by saying phones need to be calibrated to be accurate. That's also true.
Correct. Yep.
For the cost of the digital angle gauges, first of all, even the cheapest ones will measure down to 1/10 of a degree, which is
Yes.
awesome. But also, they're very small, so they're easy to get into tight places, and you don't even have to hold the reading on the one I've got, or you don't even have to look at it at the time because you can press a hold button and then take it down and look at it. So it was a whopping $18.95 at Lowe's. So
Yeah.
Oh, wow, I overpaid for mine off Amazon.
well, I was going to mention that last week, but
Man, I'm a little upset.
you probably got the chrome plated one.
It is silver. I mean, brushed aluminum look, right? So what happened?
Here's
Sorry, go ahead,
here's
Jim.
one more question for you. It just popped up from Gavin. His question is, does thrust angle need to be checked when just replacing the windshield?
That is a great question, and I would say that almost all service information probably would correlate the yes. I think all of these things need to be, especially when changing that. So I guess the question gets asked a lot. The argument I hear a lot is, well, if the car was calibrated when it was all right off the line, everything was calibrated, and then we just replaced the windshield, and I got a really good windshield guy, and he didn't have to touch the camera because it doesn't have to move. Why would I need to change anything? Well, I'm sure the suspension is settled and changed. And just think about if it was perfectly in line from the factory and now it's still green, but that's 0.2 of a degree this way and a little bit of caster and a little bit of camber and all the things are all different. We've changed the complete attitude and drive of the vehicle. So maybe just the windshield's been replaced. And that alone would warrant the calibration, of course. But if thrust angle plays such a big play into it, why would we not? If we're going to calibrate it, what if we calibrate it wrong after the windshield and the thrust angle's off? What if all of those factors would say that, yeah, we should probably check everything anytime we're going to do a calibration. Anything that could affect the calibration needs to be correct, even if we didn't touch it.
Gavin, at the end of the day, you need to ask yourself, how do I know it's right when it rolled in the bay?
Mm-hmm. And then ask yourself, what's my argument against that lawyer in the $1,000 suit? Again, don't want to touch the litigation part, but for real, I mean, that should be in your mind. If you're really worried about liability, think, am I doing what I'm supposed to be doing? Does the service information say this?
And that brings us to our next question.
Right.
Chad Whitaker, do you see that?
Yeah. Have you experienced any backlash from insurance companies about doing advanced driver assist calibrations? For example, after an alignment, the service information says recommend calibrating and the insurance company does not approve the supplemental because it's not required. Ooh, a legality question.
Yeah. Chad, I'm going to assume you're from the collision industry. If there's any other attendees out there who are from the collision industry, feel free to offer up an answer in chat.
Do I have any? So the question was actually, do I have any experience with that? And my answer is yes, I do have experience with that. And I usually just stick with, well, this is what the OE says to do, so we'll need to do this. Now, my stance on it's a little different because I'm a third-party person that's being sublet to do certain jobs. So I can tell you the part of mine that I don't know about is how many times I don't get called for that. How many times does it happen? So my experience is yes, I've heard backlash from it, and that beyond that, all I can tell you is there's current litigation with insurance companies on that.
And Brian Mann posted in chat to all attendees. He says that basically you have to present the SI to the adjuster, and they'll do it right. So if the insurance, and I've heard this, I have some friends of mine that are in that side of the business. And it seems like if you can show it to them and it's in SI because of some other experiences they've had in other areas, they seem to be pretty receptive to, well, I guess that's what we need to do. I don't think I misspoke in that.
I like Michael Phelps' response. Ask them to put it in writing that they declined to perform a necessary calibration on a safety system.
Yep, that'll probably quickly.
That might be the end of the discussion right there. And
Yeah.
I know he's a sharp mobile guy up in Colorado or somewhere up that way. So
yeah, he's up in the Centennial, Parker, Denver area.
Todd Doty is an employee at a really high-end dealership in Denver. And he says a lot of times we have to supply the insurance company with the document from Service Info, and then they're more apt to buy the calibration.
I charge for supplying service information. Anonymous attendee again, if in your experience, what information have insurance companies required for calibration reports and payouts? I've heard all kinds of spectrums. There's so many answers to that. In my experience, they want an invoice.
Yeah.
That's what the insurance company wants, is a pre and post and an invoice usually. I would urge you to document everything and keep everything. That's the best answer I could give you on that, really. So let's jump back to the class. We are semi-time constrained. I would like to finish this one up here.
We're happy to stay on to answer questions after the class completes, of course. So
absolutely, but this case study is so fun. So
well, it is. We need to.
it's interesting.
We're in suspense, Keith.
Right. Even the guys on the panel that have already seen it. Yeah. So the service driver assist message came right back on, but it was just to recap. It was after we had got done with our test drive almost. We were right back. We were just miles from the shop. We usually do about 10 miles. I think we were like seven or so miles from the shop. So we did another health check, and we have the same C1002, or well, at least so it seemed. And so we pulled up in the actual module itself, and we saw that 00 was the identifier this time. So it's got a malfunction descriptor this time. Before it was incorrect mounting, and this time it's just malfunction. So I can tell you from the time that I saw this to the time I found out where to go next, which was looking at additional DTCs, was actually almost a couple hours. There was a lot of service information to read through, a couple phone calls I made saying, hey, what am I doing? What is malfunction? What malfunctioned? I looked at lots of live data, read lots of description and operation, went through this 00 descriptor on this code. There actually wasn't a lot of information in this specific code. But what I come to find out when looking through all this information was these other DTCs. Because we need to remember system interdependence. Everything is kind of intertwined together. Everything's paying attention to everything else. So when looking at it, we noticed a steering position signal and valid data. And that was the one that, while perusing almost every one of these other DTCs, even the airbag ones, what affects this? What could cause this malfunction? Because the data was, everything looked good. It didn't make any sense. And it's kind of always, Occam's razor, I think Chris Groff brought up the other day in a different live stream, was it's usually the answer to the problem is the simplest solution. And so looking through the rest of the DTCs, we found this, and looking through all the information on every DTC, which is why it took hours, I found this one little excerpt for this 71000. And there at the bottom, the adaptive cruise control is inhibited. And apparently, when it's inhibited, it also sets this malfunction code if it does that during the calibration. So if this code sets after a vehicle is calibrated correctly, I did not get to test and this is something that was brought up to me afterwards off the stream, a question somebody else asked me that watched it. They said, will this set this C1002 if it's already been calibrated? And the answer to this was yeah, because that's what happened. It calibrated correctly. We were just doing a test drive. So this adaptive cruise control inhibited is an action that's taken by the module once that DTC sets. So this C1002 was set because the steering angle sensor was invalid. And looking at the data, it was just not calibrated. It was actually, I unfortunately didn't grab a screenshot, but I think it was 20 or 30 degrees off. So it was relatively bad. I remember the frame had been off. They had moved I'm sure the rack and pinion had been undone. So this might have been something that was done after the frame repair. This may not even have needed to be done because of the collision. This may have only been a result of moving the rack and pinion for the frame repair. So that was kind of what happened with that. So then after calibrating the steering angle sensor and driving the vehicle, we got, I actually did about 20 miles in this car because I was scared of it. It had been months and months and months. But if you look here at the mileage, it's 8542. So 3,000 miles of time that had passed in order to fix this vehicle. So documentation was super key because I had to look back and go, now, what did we do last time? I've seen 100 cars since this thing. So kind of to wrap it all up, remember accurate service information, and not just accurate as in where you got it from, but how up to date it is. Reliable tooling comes into play every time. Although we used an aftermarket scan tool, that was more of a test for this one. I would recommend, always recommend OE tooling because that's what the OE says, but it just needs to perform the function correctly. And then a big part of answering this question or fixing this car was understanding the sensing technology, how they were interdependent, how there's sensor fusion. Everything is cross-checking everything versus other inputs. There's hundreds of inputs into each module from other modules, so it's all going to play into successfully completing this repair. And then, of course, just the best practices in general. The tire pressure is a huge one, like Randy said. I mean, I think the pictures are in another class, aren't they, Randy, of the laser on the emblem?
They are. That's correct. It's in the 4-hour version of this class. So.
Right. And so it's a massive, massive change, just airing a tire up directly at the vehicle. And I think Jim brought up some better math because of his other extracurricular activities, knowing that at a certain distance farther away, the amount that it's off is significant. And we talked about that with just thrust angle. So now, maybe we didn't directly adjust thrust angle because of the tire pressure, but we changed a lot more than that with the tire pressure. We actually changed more than one axis of movement. We went down and to a direction. So it's way farther off than it would be just with a thrust angle. So those are all kind of things to play into that. So that's my presentation. We do have some more future events coming up, and I think Randy kind of gave us a little good walkthrough at the beginning there, how to get there. But I want to thank everyone for being here. And I got as much time as Randy's willing to give us, and if we don't step on toes of anyone else, to answer any other questions.
Okay. Well, we do have a couple of questions here I'd like the panel to address.
Yeah.
I want to mention first, to enroll in future virtual classroom events, go to CTI online, hover your mouse over training, and you'll see virtual classroom in the drop-down menu. That link will be in your follow-up email, just so you know. And also, we have several events in the future coming up, and don't be surprised if this morphs into something more formalized that involves certification. So watch for that. That's in the planning stages at this point. So that being said, let me stop Keith's screen share for just a minute.
Yeah, I got that.
There we go. Thanks, Keith.
Yeah, no problem.
Had a question here from anonymous attendee. Anonymous asks, how do I know if the vehicle comes with ADAS? Which is actually a very common question in a lot of service bays where ADAS may be a kind of a new thing to their area. So, any of the panelists want to address that?
I know that on Toyotas, looking at the new vehicle information, if you have that available in your factory info, or if you purchase the aftermarket or the subscription to the factory service info, what it's called, New Vehicle Technologies, Jim, or what's it? The exact verbiage of it? I put you on the spot.
No, not at all. New vehicle features.
New vehicle features.
Is not where I would look for that, though.
No.
Where you would actually look for that is, you would do a VIN search for the vehicle, and it will actually bring up where, like if the vehicle was sold into a rental program, it'll actually bring up whether there's any open campaigns and everything if you're subscribing directly to TIS. And then you can click on the configurations for that specific vehicle, and it will bring up everything it left the factory with. So that's
good for Toyota.
That's for Toyota. Obviously Chrysler has their way of handling it, and GM has their way of handling it, but I guess the default answer for me is always refer to service information. Did we answer Richard Krieger's question? Because he was asking about the recording, and what we're doing is each one of these is being recorded on our end, and we're picking the best recording to put up as a resource on the website at the end of the week. So you won't see anything for this one until next week. Keith, I have a question for you.
Yes.
One of the things I never see come up in chat, and everybody's always talking about liability and all these things, and I'm not a lawyer. I didn't stay in a Holiday Inn last night or any of that stuff. But if I was still in a situation of in the shop and doing these for my livelihood for consideration, as the law would state, I would be very, very serious about documenting system operation when I'm done with the vehicle. And so do you or anyone you know about have a procedure for documenting that when you're done, the system is behaving, operating normally with no warning signs? Do you have a way of capturing or documenting that, or do you know anybody that's doing it? Because to me, if I can prove that it's functioning as it's designed, when I'm done with it, that should
Resolve
be
you in theory.
be a pretty interesting shield against it wasn't working. I have video documentation that it was working right. Has anybody looked at that angle yet?
So I read the description of operation of the system, and if it does happen to have any specifications, I try to use my best judgment on document that, but I can't tell you that I've ever went to check a system that says that within X feet of a turn or whatever, I've actually measured that. I can tell you I've not done that myself. I don't know anyone that does. But I do try to take into consideration the spirit of what the description says about how the system should operate and try to verbalize that in my final report. There's lots and lots of notes whenever I do one of these about what was followed, and anything that's outside of the norm gets written down. Even when it's like it wants me to check something that I think is kind of different compared to others, I have a kind of basic verbiage that's used on what I check, and if there's something odd that I read, I will put it in there if I check it. But I don't know of anyone myself that's got a standardized, we do this to every car, just outside of a normal what people aren't telling me.
Yeah, I wouldn't think we're that standardized yet, but there are a lot of vehicles that with active cruise control will put up some type of a visual for the driver and whether or not it's detecting a vehicle in front. And I would think video that shows my car staying in my lane and picking up the dash and showing it detecting the vehicle and adjusting the cruise control. And then when I move over into the other lane, it sees the clear lane and reaccelerate. I think all those behaviors and showing those operations in a video attached to my service ticket would be pretty hard to argue with.
You aren't happen to be mentioning the video that I posted today on YouTube, are you?
No, I didn't
okay.
know.
Well, I posted a video today showing a vehicle in front of me being picked up by the dash indicator on a Ford and showing the brake lights, showing that it sees the brake lights, and after cruise control slowing down, then the vehicle turning off and the vehicle reaccelerating. No, I have not attached that to an invoice before, and that is probably a good practice to take that documented of notes. I currently use the verbiage that after reading description of operation, and what I can see, the vehicle operates normally. I try to use those words. The vehicle operates normally according to what I understand in description of operation.
Take a look at Dan's question in Q&A. How would you answer that?
Ooh, my glass guy doesn't unplug cameras when glass replacement. Should a calibration still be done?
Yes.
I don't know of an OE that doesn't say it has to be done.
I know of one.
Oh, do you?
Mercedes states if you are using the correct tool to apply the glue, you would not have to recalibrate.
Is there a correct tool part number?
There is, but I don't, outside of the dealership, I don't know of anybody who is using it. So I would just say, yeah, do the calibration no matter what.
Yeah. Then it goes to,
OE
did you
glass,
use the correct
OE
tool correctly?
Exactly. And I want to bring up one other question if we have time. Matt, Matt Stormont said, is there a time frame for it to mess up, like driving at 10 miles and codes come up? And I can say from a vehicle that Jim and I saw, that Camry, what did it take? How long did it take before a code set for an obvious
Almost
problem?
almost a month.
It was a month before it actually set a code.
It was at least a couple of weeks. Yes.
Yeah.
And that was for a severely misaligned radar.
Yeah.
Did anybody notice that Chad said that iCar has an ADAS search function you can use to see if the vehicle has ADAS and what actions require calibration? I thought that was a nice thing to make sure people didn't catch it.
Yep, I broadcast that back out to all of the attendees. So thanks for that, Chad.
And Michael, he says, do you mean like taking a dash cam with you? He targeted that specifically at me, and I'm saying absolutely taking something like even a 360 view, and I would have it on a mount that I could clip to a headrest, and I would make sure that it had visibility down the hood line and was picking up the dash, and I would drive with my arm out of the way. And I've actually played with the concept a little bit. So yeah, that's exactly what I was thinking, Mike, when I was talking about that.
I have one more question if everybody's got time. This is from Peter, and Peter said, I'm going to kind of set Jim and Rich up for this because they had a personal experience with a vehicle like this. Peter asks, in regard to the blind spot monitoring systems from Toyota, he had a misalignment code for both rear sensors, and it occurred after a snowstorm. After inspecting, they cleaned everything up, but they didn't visually find anything wrong. Is this something where they will need to go in and replace the sensors or attempt a recalibration first? And if Peter is still here, I'll bring him online and he can fill in the blanks.
Yeah, because I got a question about that.
And there he is. There you go, Peter. Thanks for joining us.
Hey, no worries.
So I have a quick question.
Okay.
When you say clean everything up, was there like a lot of body dust and such on the front of the radar?
No, that was the surprising part. I expected that it was going to be packed full of snow and debris just from driving down the road. We gave it a good car wash, nice and thorough. It still was throwing the codes, pulled the rear covers off of the sensors themselves, at least the bumper cover anyway, not the actual sensor housing cover. Yeah,
that's good.
Clean
Gotta
that
heat it
all
up
up.
first, use a screwdriver.
Oh yeah. Disconnected the connectors, blew them out real good, checked for any bent terminals, any water debris inside of it, everything like that. There's nothing. I mean, it's really kind of a baffling thing.
Did the operation of the system come back after things dried out, or was it?
No, it's still in fault.
Okay. So that
obviously
changes what I'm thinking. Go ahead.
Yeah, and you're pretty sharp, so I assume you've done a really good inspection of possible collision damage or anything, right?
Yeah.
No history that you can find.
Truly was intact and working, and the snowstorm occurred. They literally said they drove it 5 miles, and in the time that it took them to drive to where they were going and turn around, that's when it threw the signal lights on the dash saying the BSM was not active.
What year was the vehicle? What year?
2017 Toyota Tacoma.
Okay.
17 Tacoma.
And it's still faulting, right?
It is. It is still faulting. And the code that it's got popping up is a C1 AC1. It's a master module horizontal axis misalignment.
Yeah, that's Rich. That's the exact same. That's the exact same code as the Camry.
Yeah. I think there's actually some case study info in one of our classes about that. Pictures from that Camry, you guys.
So
played with. Yeah.
So one of those is obviously the master, and the other one is the pass through. I'm not going to claim to know that they're always on the same side, but on the On the Camry, it was the right rear that was the master, and it was the left rear that was the slave. And you can actually figure that out by looking at the schematic for the diagram in Toyota service information. The master module will be drawn with round edges, and the slave module will be drawn squared. And that's how Toyota depicts it in their schematics.
I thought the Tacomas were left-hand side was master, but
Yeah,
I'm also just guessing
Yeah.
from memory.
I'm not gonna claim to memorize it, but that's the way it'll be drawn, and it'll identify the module. What I saw and what Rich saw with the one that we had that set that is, once it had learned that there was an issue and it set that code, something had gotten so far off that even if you started to go down the procedure to try and align it with a target and get a reading, you would get an error because it was too far out. So the first thing that I would suggest is, even if it doesn't look like it, the mistake that's made a lot of times on those is that you really should physically verify the position and alignment according to service information before you even start trying to do some of the scan tool functionality, because if it's physically wrong, the scan tool functionality won't work. At least that's been my experience.
Okay.
I know that to set that code, the horizontal axis has to be more than like 5 or 6 degrees off.
Now ours was 7.5.
7.5. I think it's 5 or 6 to code. I think C1 AC1 is
and you know why? Because once you get it inside 5 degrees, it'll actually read the target and you can start to adjust and correct.
Mm-hmm.
But until you get it inside 5 degrees, going for that plus or minus 3 roughly that they push for, you just get error. At least that's been what I've seen so far.
And Michael Phelps brought up the point I was going to bring up. For the blind spot monitor, did you do the system operational check, that initial check to see where they're looking?
Yeah, and as far as I can tell, with what we've got, it's in the right area. Like I say, this is just kind of a baffling one. And talking to a couple other local guys on Toyota forums and stuff like that, they're kind of in a bad spot right behind the rear tires with not a whole lot of real protection there without mud flaps. And so you drive down a dirt road and all of a sudden you get a rock that's tossed up there and you can take the corner of the sensor out without even knowing it.
And it doesn't take much from everything I've been seeing.
So, and that's kind of why
they can still look good. Yeah, they can still look good outside, but the plastic got flexed enough to damage a film underneath or something like that.
Okay.
And Joe Z says, I've seen that code on one with an internal issue. So it's happening.
Well, that's kind of where I was headed, is that it was going to be the $2,700 in sensors and recalibrate them. Yeah.
Woo-hoo.
Yeah.
Thanks. And Peter, thanks for their patience on waiting to get to that question at the end, and thank Randy for remembering to bring you back around
I appreciate
bring you back around the room. That's awesome.
Okay, well, guys, it's rolling up close to 9:30. I think we'll probably have to wrap this up, but if anybody out there has any questions, my email will be in your follow-up. Please bring that to my attention. If you'd like to rejoin us on Friday, we're starting at 1 Eastern on Friday. And also visit CTI online to see our complete schedule.